I've got underfloor heating! I've just gone and bought 1,000 litres of heating oil, aka kerosene, at 55 pence per litre. There is 10 kilowatt hours of energy per litre of kerosene, so that makes it just 5 pence per kilowatt hour. If you're needing cheap heating fuel as well, I recommend this company. So I'm not sponsored, but I've gone on valueoils.com, and here was my quote: 1,000 litres at 53.7 pence per litre, and with delivery makes it £580 roughly. And it's with that stuff is what we run our combi boiler with. So let me just give you some perspective. Let's say you're relying on electricity for your heating. Even if you've got a heat pump, you're paying way more than if you had one of these. As previously stated, a heat pump is a 1:4 ratio at best. So there you go, a few maths through ChatGPT, and it says between 8 and 14 pence per kilowatt hour for a heat pump. Now you may find this interesting, but our exhaust also goes into a polytunnel. And so basically the extra carbon dioxide and heat gives us an extended tomato growing season. And they taste great. Sorry about that, it's a squirty. So fun fact, CO2 generators are a thing. In fact, commercial growers use them to get a 20% increase in yield, which is basically the same thing as a paraffin heater. Paraffin, FYI, is basically the same as kerosene again. There you go, kerosene basically is paraffin. Which if you think about it, makes a lot of sense why the dinosaurs grew so big, because there was 10 times the amount of CO2 levels, which meant all the vegetation also grew really, really well. And the chickens love it too. So what about carbon monoxide, you might say? Well, I've got an air quality monitor and a CO level monitor. Alright, so I've left it on for a few minutes. We can see we're showing 0 parts per million currently. I did try and test it earlier with a lighter, managed to get to 11 parts per million. These things really go off when you're using a petrol engine. FYI, don't test lawnmowers in a cramped workshop. But what does the air quality say? It's saying it's excellent. The humidity is rising because you're actually getting a lot of water vapor come out the exhaust. It's part of the chemical reaction. You actually do get water from the combustion. I bet this is really loud. Let me turn it off quick. All right, I'm back. So kerosene, believe it or not, is almost identical to diesel. The only thing that's missing are lubrication additives, which basically means that kerosene burns very, very cleanly, and in fact produces far less carbon monoxide than any other burner system. Okay, so we've established it's both cheap and it's safe. That's correct, I said safe. It doesn't combust like petrol or gas does. The kerosene has to be either atomized or wicked for it to combust. Let me prove a point and show you. Right, so here's a litre of kerosene. This is a blowtorch. Exhibit A. Fine. So you can see it's not combusting, blowing up everywhere. In fact, if we just have a little spill. It just won't light. But if we wick the kerosene with a paper towel, let's say, we're now wicked like a candle wick. Now she'll stay alight. Ta-da! What's that showing it parts per million now? I'm pressing the button to test it. Alright, now 53. Oh, our air quality monitor said it's serious. Alright, it's finally dying down after a few minutes of burning. We peaked 72. So we peaked 72 parts per million. But the air quality monitor says my asthmatic neighbour is going to die. So just off camera, the VOCs and formaldehyde levels also peaked at dangerous levels. So you're probably thinking, hang on Josh, I thought you said kerosene was safe. Well, it's a relative term compared to storing gas or other combustible fuels. But what you saw was an incomplete burn. That's why you have all those toxic gases coming out. And basically my boiler and diesel heater will be able to create the right temperatures and oxygen flow to get that complete burn. So there are actually other gases that I'm unable to monitor that have danger to health as well. So we've got nitrogen oxide, sulfur dioxide, polycyclic aromatic hydrocarbons, aldehydes, ammonia and hydrogen sulfide. Those are toxic and known carcinogens. And so it's the safety, the air quality and the environmental impact that people are most concerned about with these burner systems. So here's my 2 cents on how I feel about it. I believe if it's good for the trees, then it's good for me. As far as climate change goes, if that is in fact a man-made thing, then I believe other pollutants, including cloud seeding, are the culprits. Alright, moving on. When it comes to air quality and the cancerous and toxins that are out there, what I don't think a lot of people are taking into consideration is the fact that nearly everything is a carcinogen and toxic. In fact, your body is constantly destroying cancers and filtering out toxins. If you overwhelm the system, yes, that's a problem. But what a lot of medical professionals aren't addressing is your immunity and health, which is directly affected by diet. If your diet's full of seed oil, sugar and carbohydrates, your immunity is kaput. And from what I have seen personally, the medical professionals will prefer to have you on some sort of medication rather than you change your diet. I could rant on all day about those, but we must move on. So lastly, air quality. Yes, if you've got, say, thousands of these heaters all in a very confined area, that's a problem. So if you live in a built-up city, then one of these isn't ideal. I lived in a city once, terrible place. And now our overlords want us to live in 15-minute cities, don't they? So cram us all like sardines where we pollute each other even more. The way things are going, I might even consider moving to Alaska. So I'll pour all this into my diesel heater. Does it smell? Well, just now it does, but that'll disappear in like 2 minutes. FYI, the original pump is still working fine. Lots of mechanics said that I was going to wear this pump out because I'm not putting genuine diesel in it. And that's because, as I said, the kerosene doesn't have the lubrication properties. So yes, these will wear out. I think diesel currently is like £1.45 per litre. A new pump is 20 quid. So you do the maths on if I'm saving money or not. So then, diesel heaters, just like the one I just showed you. This is what I'm calling the bare bones model. It's currently £80 British. So without a doubt, this is one of the most cost-effective heating systems money can buy. And that tank over there is worth about the same price as a full tank of kerosene. You've just got to install a decent concrete pad for it to sit on and away you go. And I can easily link that system straight into one of these. If you do it yourself, you can fix it yourself. You're saving in maintenance costs also. Will your insurers be happy about it? Of course they won't. And I would also say if you're not a believer in natural selection, then you shouldn't attempt to install one. This might not produce very much carbon monoxide, but if you fill your property with carbon dioxide, you'll die from asphyxiation. So make sure the exhaust goes outside, okay? The exhaust is hot also, so make sure there are no combustible materials around it. It should be common sense, I know, but some people don't have common sense, do they? So then previously we installed this air cooling method to the exhaust. So the idea is to extract as much of the wasted heat out of the exhaust as much as possible. So you might have missed it, many did, believe it or not, but in a previous episode I created this. This is an aluminium heat exchanger. Exhaust goes through here and water cools it. And so my hypothesis is that I'll now have hot water that I can then use for underfloor heating. So before we do, I'm going to give it a service. I think we can drain it via the fuel switch that we added. I think I've also decided I'm going to remove my auxiliary tank. I was putting waste veg oil mixes in this and it was very cheap for sure. But waste veg oil is increasingly hard to get hold of and it's actually quite a faff to process, so I'm not going to bother with this anymore, I don't think. By the way, that is exactly why you want a fuel filter. And also to not have your outlet pipe go straight underneath your tank. Just gives it a chance for all that rubbish to sit at the bottom rather than go through your system. Now it's all degraded, I'll need to replace that, I think. Bought a spare pump just in case, but I think this one's good to go for many more years. And because of doing water cooling now, I might as well take all of this off as well. I didn't realise it still had sand in it. So this is definitely something to make note of. This here's the carbon build-up inside the exhaust. I don't quite know how I feel about that. A lot of this is probably from me burning waste veg oil in it. I'm thinking, because my water cooler is going to be a shorter length, that we won't get as much carbon build-up. I guess for maintenance, we could just run a pipe cleaner through it. Just do it annually like you would do a wood-burning stove. Right then, let's look at the damage. Right, so I've just taken it apart. My first concern was how the rubber mount was so degraded. So I was a little bit concerned when I looked at the exhaust port. Most of that is just melted on rubber. However, we are getting some carbon build-up in there. The glow plug, however, still looks really good. I've gone ahead and broken the gasket again. But moment of truth, let's have a look inside the chamber. So there's a bit of carbon build-up, but otherwise looks quite clean. I'll scrape that into an ash pan in a minute. The rest of it, to my eyes, doesn't look too bad at all. I think I'll simply give it a wire brush. Now let's just see the condition of that glow plug mesh. So again, I've mushed it trying to get it out, but the condition of it actually isn't too bad. I've got a bag of replacements which cost hardly anything, and all of these maintenance parts I've put in the description for you. Well, I would say that's good to go now. I'll just stick the new gaskets on, and I think I'm going to mount this slightly differently. So there we go, she's fully clean now. I used a polycarbide brush around the exhaust outlet, and I found these cheap little wire brushes were good for getting it on the inside. So for the gaskets, I bought this pack. It actually came with gaskets for the 8 kilowatt and the 3 kilowatt version. I'm guessing so if you're in doubt, you just have both, don't you? But I didn't realise it, but this pack also came with a little mesh part and a spare glow plug, and handily, a special glow plug spanner. So I can now finish putting it together. So I'm going to continue using the old glow plug, nothing wrong with this one. Back on the motherboard, that will go in the 4-pin. Temp sensor will go on the 2-pin, and the motor goes on the 3-pin. Done. There we go, good as new. Yeah, I've decided I'm going to get rid of all of this. It's just in the way. It makes maintenance really difficult. This is my air inlet pipe, by the way. This also, like the exhaust, needs to go outside. Otherwise you create negative pressure in the room. If you're sucking air from inside the room and exhausting it outside, well, that's a problem. But you know what? I'm probably going to rearrange all of this as well. Essentially, I'm starting again. That's all that off. So just remember, I ruined my wall, so you don't have to. So my walls, by the way, are made from steel-clad Kingspan insulation. Anyway, for fixings, I use riv nuts. But my tip is to add a little bit of glue to these. I'm using JB Weld epoxy, because on very thin material, they can start turning, and therefore you can't get the bolt back out again. Here we are. Because I can tell you now, when this happens, it's very frustrating. See, there's just no way I can unscrew that. The whole thing moves. So to mount this, I've recycled the L brackets, and cheaply I got hold of one of these heater mounting plates. So I've just cut out a square hole for the exhaust to go through. I'm not sure how much heat is getting recovered, so it's good to have a bit of an air gap. We will be monitoring the heat and everything, so if this is getting too hot, I'll expand it if needed. So we actually need a 32 diameter hole, and I found for sheet metal these hole cutters are the best. I'll just hand tighten this on from the other side, and then you guys can watch it cut. And the cuts are exceptionally clean. So for the air inlet I just need a straight hole, and the cutter won't work for that, so I'll have to use a step down drill bit. For the air inlet though, I've got something very interesting to show you. So then, let's assemble it all together. I ummed and ahed whether to put a rubber back on it again. In the end I've decided not to. All that means is from the blower, a lot of air is going to escape around this hole here. Because we've got the burner inside, that's not really a problem. But if I had this unit outside, then we'll lose a lot of efficiency that way. I've also decided to put some spacers there as well. So the next part I'm fitting is the air intake. And as you can see, it's the same stainless steel exhaust material, except I've put a little pigtail in the end of it here. Take the filter off, post that through there. Don't forget the universal clip. Next I've got another short piece for the actual exhaust, and for a sealant I've got gun gum, an exhaust sealer. Hence why I'm wearing gloves. It's got a very funny texture this stuff has. And basically I'm going to feed this through the pigtail. This has created an air preheater. Now there is much debate on this. It's true that if we have cold air going in, it becomes more oxygen dense, therefore you get more energy in the burn. But with hot air, you get a much cleaner burn, as it takes less energy to get the ignition. Now what we don't want is the hot air being too hot, otherwise you'll melt that little fan inside. So I thought one coil will be enough, and we can test it against our previous data. So I've made a little bracket here, I can just slot it on now. To finish the exhaust off, I've bought one of these. However, I've quickly realised that I've drilled the hole the wrong size. That's 32, this is 38mm. I don't have a big enough drill bit, but I do have a hole saw. So to resize it, I'm going to do the hole saw within a hole saw technique, because the pilot drill bit is going to do absolutely nothing now, so it'll go all over the place. The idea is to use another hole saw, the same size as the hole already created, to make a bigger one. Well, that looks very neat. However, I've realised that the condensation is going to drip out here and come against my wall, which is steel. That's a problem because it's carbonic acid that's coming out, which is basically the same as fizzy water. It's just carbon dioxide dissolved in water, but because it's slightly acidic, it's going to corrode my shed away. Now, you may have noticed, but on the muffler, there's a little hole there. That's exactly what that's for, to exhaust all the condensation. However, it doesn't fit, as you can see. So I think I'm going to resort to using one of these little pipes instead. So now the condensation will just drip on the ground here, which according to some is really good for plants. I'll keep you posted if anything grows. So moving on to the pump and cable management, I've stuck onto my wall a handy electrical box. Now someone will say that I've done this completely wrong. That's because they believe it must always be at a 30-degree angle. That is relevant for horizontal systems, like inside of a van. And the idea is that we don't get any air traps that would damage the pump. So having the pump go vertically is also absolutely fine. What I'm also going to do is pack it with this synthetic wool. And I specifically chose this because it's flame resistant, which is exactly what you want in a system like this. So lots of people complain about the sound of the pumps, so I'm hoping that the wool will deaden that sound. We'll test that with a decibel reader shortly. And just below I've added a new fuel filter, and for reference this is what the old one looks like. Again, worth changing every year, I think. For the fuel tank I've got this 25-litre barrel. You can find these for free and are often used for distilled water. On the end of the fuel line I've got this mesh filter. This also has a built-in one-way valve in it so the fuel doesn't come out when I lift this out. And then on the cap of the barrel I've added a little breather. So for everyone who's not putting in a heat exchanger, we're pretty much done. All you've got to do is mount your control panel and attach a suitable 12-volt power supply. We'll talk more on the power supply in a moment, but right now I'm going to move on to the plumbing. So I'm going to begin by adding this small radiator. The importance of this is going to become apparent in a minute. So between the radiator and the heat exchanger, I've got this configuration, which consists of a very affordable hot water circulation pump. These are fantastic. I've had one for 10 years, water cooling my forge. And then just behind it is a wire strainer. I'll show you what's inside quick. As the name suggests, it's got a wire strainer inside it. This will collect any bits that are in the system before going into the pump. It will basically help this pump last as long as possible. When I built my heat exchanger, I only had 20mm pipe, which doesn't fit the standard 22mm copper pipe. And there's another problem to think about. Aluminium and copper both expand and contract when heated at very different rates. So instead, I'm going to slot one over the other and use a sealant. And I found that CT1 is actually incredibly good. It's very strong, it cures in the presence of water, and it has good flexibility. I use this on a lot of stuff these days. There you are, tidy. So the other thing to think about is electrolysis. Copper and aluminium don't like each other and they will start corroding. So I'm hoping the CT1 will create a nice little barrier between the two. But just up here I've added a reducer for 15mm PEX pipe. That's now going to be our underfloor heating. So we can of course make this fast, high quality and cheap. Only problem is we can only choose two of those. Meaning if we do it fast and high quality, it won't be cheap. But if we want to do it, say, cheap and high quality, then it won't be fast. So because this is an experimentation, I'm going to go for the cheap and fast option, which unfortunately isn't going to be high quality, just so you know. So I've pulled out my hedge, an off-cut panel. I got all of these for 30 quid, by the way, from a farm auction. And some 15mm PEX pipe. This was left over from a job I did years ago. And it turns out this is perfect for underfloor heating. Right then. Right, so far, so good. This pattern, by the way, the spiral pattern, is meant to be the most efficient for underfloor heating because the hot input starts around the outside and then comes in between your cold returns. So it goes hot, then cold, then hot, then cold, then hot, which essentially means you get a more even heat distribution. Let's say if we started the other end and did the typical snaking pattern, well, this end would be hot and it would gradually cool down this side. Whilst doing it in the spiral pattern, we get a more homogeneous heat distribution. Well, I sound as though I know what I'm talking about, don't I? But in reality, this is my first time doing it, so what do I know? And one of those didn't go very far, did it? I'll put some weights on this and see what it looks like in the morning. Alright, well, hopefully this has worked. So this is a wall panel, it's not designed for standing on. It is strong enough, however, but this is a way too slippy surface. So I've got some special grip floor tape to give us some traction. Should have brought more of that. Right. So even though this is made of junk, I'm still going to take my boots off. No screenshots, thank you. Something a bit uneven. Well, it's a floor. I need to redo my actual floor anyway. I did all that cheap and quick as well. It's literally just the clay ground, a membrane, some sand and paving slabs. That's it. And I got the paving slabs for free. Anyway, let's finish plumbing it in. So then, this is the flow, this is coming from the heat exchanger, and this is the return going back to the radiator. Alright, so I'm going to match the pipe about there. I bought this tool off Amazon for about 8 quid. Cut 64mm apparently. And came with a really good little reaming tool. There we are. Alright, and now for the return. Goodness me, it's raining a lot now. Your poor horse is getting wet. Right, so I think we're ready now to fill the system with water. What I have to do, as someone's probably screaming at me at the moment, is I need to put bleed nipples, sounds very painful, in all the peaks of the system. So all the mountain peaks, if you like, the very top points, they need to be drained of air. We've got 2 peaks in our system. We've got the radiator and we've got the heat exchanger. This is a very high point. So the best place would be to install one right on the tippy top. But I should have thought about that before installing it because I've got no room for the drill now. So instead, I'm going to come from the side near the very top here where I've ground a flat. And for the plug, I've got a self-tapping roofing screw with an O-ring on it. Right, I've taken it back out, just so when we fill it with water, all the air can escape from this high point. So coming back to the radiator, I've added one of these funnels. These are for adding an inhibitor like this, because basically in an open system where the water can get oxygenated, that will eventually start corroding the radiator. However, because this system is in my workshop, it might be a case that we get freezing temperatures. So I might want to add an antifreeze instead. But right now, I'm going to use it to fill it up with water. Oh, that's helpful. Oh, well, that can get closed off now. Yeah. So we're now full to the top of the radiator. I'll take this off. I'm going to add a radiator bleed valve. And I'm going to use the bleed valve as an air vent. So I'm going to make sure it's fully open. In fact, I've taken the whole screw out. Now this is actually incredibly important. This must remain an open system. If not, as we bore the water, the system will become pressurized and something will give. So we're now ready to talk about the power supply, but before we do, I want to build a shelf with these brackets I made. So then let's quickly move on to powering one of these, how much it costs and what the options are. Since I first installed the heater, I've been using this power supply. It drops 220 volts down to 12 volts at a maximum of 25 amps. That's 300 watts. So the heater itself uses 150 watts for just 1 minute. That's to do the glow plug. After that, the running usage is 40 watts per hour. And last time, when my energy bill was a lot higher, it was just 1 pence per hour to run the thing. I'm paying a little bit less this year, and with the pump, I'm expecting it to still be 1 pence per hour. But there is a major flaw in using one of these, and that is if we ever have a grid down situation. And according to some people, in the UK at least, that's going to be happening more frequently, as apparently there is an energy crisis. And the main issue is, if we lose power mid-operation, you could damage your heater. It must run through a cool down cycle when turning it off. That means once you've pressed the off button, it will keep running the fan for a few minutes after. If you don't do that, then the heat that's still left in the burn chamber could fry your motherboard. So what's a better option then? That would be to use a battery and have a charger like this one permanently hooked up to it. I've had this one for 10 plus years and it's excellent. What's great is it keeps the battery in excellent condition and it'll even repair the battery if needed. This is the old version, but I believe this company does a 6 amp version, which is about what the diesel heater uses. So I would simply connect this up, plug it in, and also attach the positive and negative to the battery straight to the heater. Now with a lead acid battery, there's something you need to be aware of, and that is, let's say you don't have it hooked up to the mains power and you just want to rely on battery power. Whatever the battery is rated for, let's say it's 100 amp hours, you're only ever going to actually use half of its capacity. If you use past its halfway mark, you actually damage the battery. Now interestingly, the heater will turn off automatically. As the voltage drops below a certain point, it warns you. But whatever the electrical device you're using, you can follow this formula to determine how long a battery will last. So first let's look at the device we're using. In this case it's a diesel heater which uses 40 watts of power. If you divide that by the voltage, in this case 12 volts, then that shows us it uses 3.33 amps. That's also the amp hours, how much it uses per hour. So if you take a 100 amp hour battery and divide that by the 3.33, well, it says 30 hours of use. But like I said, you're only able to use half of that amount, so divide that by 2, which means we can run the diesel heater for 15 hours. You can apply that same formula to anything. So let me now introduce you to a third option. And this is why I needed a strong shelf. Da, 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 da. So this is the AFERY P210 2400 watt and gives us 2048 watt hours of power. Currently it's just over £1,000 with an extra 130 quid off. And I'm actually currently testing a number of these solar power stations, but this one in particular is very good for diesel heaters. And that's because of this port right here. This does 12 volts at 25 amps and has an XT60 connector. And just above is a typical 12 volt 10 amp car port. So on all the other power stations, that's what they typically use, the carport. However, there's a big issue with these. As we said before, whilst using the diesel heater, we use 140 amps when using the glow plug. Divide that by your 12 volts, and you've got 11.6 amps that we're using. So that's nearly 2 amps over the limit, which means these get hot and can break. But with the XT connection, we don't have that problem anymore. So these can obviously be charged just using solar panels. Now AFERY claim that this will do 3,500 charge cycles. And because these are lithium iron phosphate, we can actually use 100% of the battery, unlike your typical lead acid. And when I talk about life cycles, that's also the equivalent to 3.5 years of constant draining and reusing. After that period, it'll only have dropped by 15% capacity. They're also giving 7 years manufacturer warranty, and they've given me an extended 5 years warranty on top of that. Actually, the interesting part, as AFERY said, Test it against all the others and see what you think. They know that I rip apart other people's products and find all the faults that are wrong with them, so for them to boldly say, yeah, go, test it, do what you like. Give us your objective opinion, Josh. I thought, fine, I will. They gave me some very bold claims on how well this performs, so I will be doing thorough testing. And for those that are interested, we've got two 40-volt power on the side here, 3 sockets there. It can take 500 watts of solar input. You've got your typical USB ports, a nice flap at the top here for your cables. And in grid-down situations, which is very handy, it's got a light. That apparently only uses 1 watt of power. This is the biggest screen I've ever seen, by the way, on these units. And I've got the equivalent solar charging stations by Bluetti and EcoFlow to test against. More on that to come in the future. But what I'm particularly liking about AFERY is they give you a dust cover. Very helpful in this workshop. And well, AFERY have been very kind by donating one of these to my competition. So for just £5 a ticket, one of these could be yours. The competition is hosted by Raffles, which is approved by YouTube and is hosted in the UK. If we click on the previous winners, you can see Jason won the Falcon 2 Pro 60-watt laser engraver. Ian won the Jasic Evo TIG. Excellent machine, I must say. And Tony Brown previously won the EcoFlow Delta 2 Max. And I do free international shipping. I'll put a link to the competition just here, and I've also put it in the description and the comment section. There's affiliate links also to this and all the equipment that I've used in this video. So then, I got myself a full tank of kerosene, start putting it through the system. Better than some wines I've tasted. I can clip into that. And now on this particular controller, I'm going to press that button and that button at the same time. And immediately it says H off. I want to turn that to on. That's basically the pump for priming. There you go, it's slowly making its way up. Right, I've turned the pump off. I've still got a bit of an air bubble in the filter here, but I can see fuel is actually going into the main burner. So I think we're now ready for the test. And yes, I still need to insulate this door. Right, so here are all the devices that I'm going to use to conduct the test. First of all, I'm going to mount the carbon monoxide detector in the correct position. A lot of people need to know where these actually go, so I'm going to do that first. Next, I've got the anemometer. So this gives us both a flow rate and temperature reading. With this, we should be able to work out exactly how much energy is being lost through the exhaust and how much is coming out of the blower into the room. And that way we can figure out how well our heat recovery system is working. Next, we have the decibel reader. It's hard to judge how loud something is from a video, so this is very helpful. Lastly, we've got our air quality monitor. It's bleeping at the moment because I've been messing around with some resins. It says that the formaldehyde levels have risen. But for those that are interested, I'm going to be testing this outside to see what the pollution levels are like, because that seems to be what most people are concerned about. Next, I've got a bag weigher, and this is to weigh the fuel. So I'm going to set a timer and weigh the difference in fuel. That way I can see exactly how long my tank will last me. And lastly, I've got my phone, and on it I have a thermal imaging camera. This is the Ulefone 18T Tough Phone. I've been testing this in some of my recent videos, but it's also got a port for an endoscope or microscope, got a 108 megapixel camera, it's also got a built-in microscope, and of course the infrared heat vision camera. There'll be a link for this also in the description. Let's begin. These need to go 4 inches below the ceiling height. Guaranteed someone who thinks they know what they're talking about will disagree with me. Do your own research. Carbon monoxide is different to carbon dioxide. Carbon dioxide is very heavy, it drops down below. That's why a basement or a cellar can be a dangerous place if you're burning wood, because the carbon dioxide will drop to the lower levels and displace the oxygen. Therefore you'll die of asphyxiation. Try searching the tragic dry ice challenge. They're no longer here to tell you about it. Carbon monoxide, however, is very light. It's buoyant, it travels upwards, but it's far more deadlier than CO2, as I noted earlier. So technically, you should have air vents at ground level, which I pretty much do, and carbon monoxide detectors up high. Hope that helps. Let's move on. Let's see how much fuel we've got. 20.3 kilograms. For the boys across the pond, 44.8 pounds. I have no idea what gin is, but 40.6 of those. Let's fire her up. With nothing on, it's 44 decibels. Okay, so the pump has made it rise to 50 decibels. As you can see, when I talk, it rises to 67 decibels. So with both my little LED lights and the pump, we're getting 23 watt hours. Turn off the light. Let's drop to just over 13 watts. All right, let's make a start. And I've set a timer. I've set it to 5.5 hertz. That's the pumping speed. And I've set the fan speed to maximum. So the pump's just kicked in. I've turned the lights off and it says we've got an output of 124 watts. All right, so the fan's on maximum power. Coming straight out the exhaust, I've got 160 degrees Celsius so far. It's still climbing at 180. Coming out the bottom of the exhaust, we've got 120 degrees. That's a bit disappointing. I thought we'd be capturing more than that. So immediately just looking at the outputs for our underfloor heating, looks like it's working. So looking at our panel, roughly 3 minutes in, so we're at 15 degrees Celsius at the moment. See how it looks in a couple of minutes. So with both the glow plug and the light being turned off, we've got a running of 72 watts. I switched off the charging. It seems to think that this battery will keep it going for 22 hours at full blast. So we've got 60 degrees Celsius coming out the blower. We started off at roughly 17 degrees Celsius. We're now 13 minutes in and we've already gone past 20 degrees Celsius in here. I'm getting toasty. Normally I don't turn my heating on unless I go below 10 degrees Celsius. So I think this is going to be a very short experiment. Decibel reader says 65. So what if I just turn this onto its lowest setting? Right, we're on 1.7 hertz now. Let's drop down to 40 decibels. And so the most irritating sound is the pump. I'm not sure how to make that quieter. Look at that! I've got underfloor heating! That's so cool! Although looking at the readout, I've got 23 degrees here on the floor, but my pipe's already at 40 degrees Celsius. So the heat's not conducting through the surface here. Has to be my expanding foam glue. Turn this down again just so you can hear me. Right, disappointingly, the phone thermometer maxes out at 150 degrees Celsius. Looks really good though. We've got my radiator up at 47 degrees Celsius, and all the pipes are showing that they're working. However, I've gone and fished out my kiln probe. This was reserved for my new gasifier video. More on that later. Alright, so on the top of the exhaust, we're peaking about 400 degrees Celsius. And at the bottom of the exhaust, we are peaking 254 degrees Celsius. And the hot water output, currently on 47 degrees Celsius. And the actual blower output now is 150 degrees Celsius. With 25 degrees Celsius, I need to stop the experiment. As for the runtime of 47 minutes, I'm going to leave it running, make my way outside, we'll do some air quality testing. First thing, I'm surprised how loud it is. 72 without the muffler on. So without the muffler, with the muffler. Without muffler, with muffler. Dropped it a little bit. Alright then, so we are 1 metre away, been here a few minutes now. And it says the air quality is excellent. So my conclusion is, unless you're using really dirty fuels, these things are just so good. On a really cold day, you'll see a lot of condensation. Like it'll look like smoke coming out, but all that is condensation. But that to me says there's really nothing to worry about. But I tell you what, that is way too much wasted heat coming out of there. And it's performing so much worse than our other experiments. And although this is working, I feel like this could be performing better somehow. I mean, I can barely feel it coming through that. Must have just used the wrong glue. Yeah, but those pipes are roasting, 45 degrees Celsius. But I'll tell you what, the radiator works fantastic. I think I'd be more inclined to try and find lots of big ones of those and have them dotted around the workshop. This, however, I don't think is good enough. You may notice it looks almost exactly like an EGR cooler, which is essentially exactly what it is, although they're a lot better. This is what I mean by an EGR cooler. This was the cheapest one I could find. As you can see, it's got lots of little pipes increasing the surface area. This mine's only got a single pipe going through it, which means it's not as efficient as these. So I think I'll have to come back to this and build an even more efficient heat exchanger. I'll probably go back to using a 2 metre pipe that we used before, but have that going inside a cylinder of water. Yep, the surface area of this one could be improved a lot. On its low setting, by the way, we're only drawing 20 watts. The max power is just too powerful. Oh, that'll do. Let's turn it off. Notice that the pump is stopped, but the fan is still going. Very important. So it's the very next day. I had to sleep on it, and I want to redo part of the test. I want to quickly modify this. Basically, because this was compressed, I thought the expanding foam glue wouldn't be a problem. But this performed so poorly, I want to try and remove it and put a different thing on top. So I've made sure to expose all of the pipes, so there's nothing covering the top of them now. And I've loosely put on this checker plate, and this is made from aluminium. In theory, it should radiate more heat, and this should conduct more heat. So let's give this a final test, and then draw some conclusions. Right, so we've got a starting temperature of 12 degrees Celsius. So power on, burner on, timer on. Workshop temperature, nearly 16 degrees Celsius. Carl Pilkington is unhappy. I really believe this is definitely deadened the sound of the pump, by the way. Tell me what you think. So without the cover, with the cover. Although the fan's going up now. It just hit 3 minutes. Yeah, this maxes at 180 degrees Celsius. So there's a chance actually that the aluminium is too reflective. You can kind of see my heat reflection. So I need to fix that. Bit of stove paint should fix that. There we are. That's less reflective now. Well, admittedly, that wasn't the wisest of moves. There goes the room temp test ruined. Shouldn't make any difference to that though. We are just over 30 minutes in. We can see it is beginning to work. Compared to everything around it, it's hotter by 7 degrees Celsius. However, I wonder what you guys think about this. So the hottest part of the heat exchanger, we're getting about 47 degrees Celsius. That's going into the PEX pipe, which is about 40 degrees Celsius. But then on the return, as it goes to the radiator, that is 38 degrees Celsius. It'll be interesting what you guys think on that. Right then, we're approaching the 1 hour mark. Let's check out progress. It's now risen to 21 degrees Celsius. The aluminium is obviously absorbing that heat a lot better, and therefore it's a more even temperature. Despite the workshop being open for the past 40 minutes, the temperature's still risen to 22 degrees Celsius. Oh, and Carl's just turned happy. If we check out the radiator temperature, it's roughly 49 degrees Celsius. A heat exchanger's on 52, and interestingly, it says that on the plastic of the blower, 65 degrees Celsius. However, if I use my temperature sensor, 146 degrees Celsius. That was the actual air, I'm not touching anything. Alright, I think that'll do now. So 2 hours in total, how much fuel did we use? So we're now down to 19.57 kilograms, or otherwise 43.16 pounds. So with a little help from ChatGPT, the difference in weight is 0.76 kilograms of kerosene, which works out to be 0.95 litres that we used over a 2 hour period. So in total, that was just over 9 kilowatt hours of energy, or 30,967 BTUs. That means the diesel heater itself was averaging 4.54 kilowatt hours. So again, that is not an 8 kilowatt unit, which is what it was advertised as. But because we're wasting so much heat outside, it's hard to know what the efficiency actually is. So to measure the efficiency, you might remember I mentioned this. Well, the temperatures, as you saw, are too great. It will melt this, as we have done before. So then, moving forward, I'd love to know what your thoughts are on this experiment. You might be thinking, Josh, if the end goal is hot water, why don't you get one of these? Why not indeed? I'm actually getting one. I'm just waiting for it to arrive. And with it, I'm hoping to build my own insulated large-scale hot water tank. So I can run all the central heating, run a bath, maybe even a hot tub. But these things are cheaper. The only problem we have is recovering the heat from the exhaust. Let's say, for example, 20% is being lost outside. Well, that means every pound that you spend on fuel, you're chucking 20 pence away. So we don't want to do that. We want to keep it inside the room. So if you're thinking about installing one of these for your home, the best option probably is to have all of this outside and then duct all the hot air in, just for safety and all that jazz. I like having it inside so I can keep an eye on it. Keeps it out of the weather, and I do get more efficiency that way. Right, so let's just finish with what I hinted at earlier, my position on climate change and global warming. Now listen, I try my very best to view and consider all data objectively, and I see it as a very good thing to question what I'm being told to blindly follow. I believe it's vitally important to look at all sides of the matter, and by doing so you generally find that nothing is black and white, and the truth is never that clear. So for a lot of people, it's very hard to care about global warming when you're both cold and skint, especially when those who are trying to punish CO2 producers are themselves travelling thousands of miles around the world in private jets, to talk about it, when they could have just used a Zoom meeting like the rest of us mugs. And not to mention that those very same people are buying up beachfront real estate despite rising sea level predictions. So firstly, we're led by a bunch of hypocrites, but that's nothing new, is it? Now this is information that you can research yourself. The atmosphere is only 0.04% CO2, which has risen by 33% since the Industrial Revolution, meaning that it was only 0.03% at one time. Now understand this, that below 0.02%, all life on Earth ceases to exist. And as I mentioned previously, there was 10 times the current levels in our atmosphere, which contributed to an abundance of life like no other time. You can also find evidence of a far hotter climate, just like in Iceland, where there are fossils of temperate climate plants, whereas today it's far too cold in that region. Also, we're still in an ice age, believe it or not, because we have permanent ice on the land, whilst that wasn't always the case in Earth's history. Crude oil, by the way, comes from ancient algae and can be grown yourself at home to create biofuel. And that's using nothing but the sun's energy and an air bubbler. Just watch Cody's lab, he did exactly that experiment. Now the actual shocking part, which should bring some revelation, is that humanity has only contributed 3% of all CO2 emissions in the atmosphere. That means 97% has all come from nature. And by the way, the 3% of 0.04% of CO2 in our current atmosphere is only 0.001%. So look, if that's true, then mathematically, even if the entire world stopped producing CO2, meaning nothing is breathing anymore, then it will make zero impact on global warming and climate change. It will simply continue regardless. Now, I'm actually reading the rising temperature changes very differently to what is being projected by mainstream scientists. I'm not a scientist, I'm just a grumpy git in a shed. But hear me out. This is what the data says. Right, so the data is that in recent history, industry has increased. At that very same time, CO2 has increased and global temperatures. But those are not the only factors. For a start, we've seen a huge amount of sunspots radiating towards the Earth over the past 60 years. That's definitely a factor. We also have a huge amount of concrete, asphalt and paving over our land, which absorbs heat from the sun and then releases it back slowly. Also, the covered land stops water from the rain being absorbed, and instead it's all moved into drains very quickly and into the rivers, which causes them to flood. But this is the biggest factor. We have permanently deforested at least 420 million hectares of forest since 1990. I mean, since I've been alive, there's been an area the size of Europe that has been destroyed. And here's a key thing. Trees have this amazing ability not just to absorb CO2, but they control climate and regulate water. Have you ever noticed how cool it is in the woods on a hot day? Do you even spend time in nature? For example, one English oak tree absorbs 68,000 litres of water a year. Just one. Think about that. Britain actually used to be one huge forest, but now because of industrial farming, it's become a wasteland. The soil biology is dead, the rivers are dead, there is mass extinction of insects, and we wonder why. Now this used to be taught at school, but the more CO2 there is, then the more plants, trees and algae keeps growing, which negates excessive buildup of carbon dioxide, which also increases the acidity of the ocean, killing further habitats. So the government's plan to tackle this is extra taxing, increasing the cost to the most vulnerable, and increasing restrictions so you can't use cheap and reliable energy. To me, this doesn't make sense unless it's corruption. But the climate, without doubt, is changing. I'm not denying that. And I strongly recommend watching the documentary called The Dimming for another perspective on that. So in conclusion, I believe that CO2, carbon dioxide, is the least of our worries. Climate change is happening. It cannot be stopped. So the only thing I see to do is to adapt and use what is abundantly available. There is no evidence to say that climate change is the end of all life. And instead, there is a lot of evidence to suggest it supports even more life. Personally, I want nothing from the government. Instead, I want them to stay out of my business and stop stealing and wasting my hard-earned money on things that benefit no one other than themselves. As it's been said before, you either know your history or you trust government. You cannot do both. However, I actually am a reasonable man. If you agree or disagree with anything that I've said, the important thing is that there is discussion. No one should be silenced for voicing what they believe, because they could be right. So look, if you've got a good argument against anything that I've said, then let's hear it. Freedom of speech is welcome here. YouTube might regulate it, but I welcome it. Otherwise, it would mean a lot to me if you subscribe. For you, it's going to cost you absolutely nothing, but to me, it really makes a difference. And it'll enable me to find the most cost-effective solutions to the rising costs of basic living. If you like this video, then can I recommend this one? Otherwise, can I encourage you to stop watching, get out there in the real world, and to forge for yourself a life worth living? God bless you. Goodbye.